Number 16, this is the equation of a circle. It tells us that, and they want us to put it in standard form. So to put this circle in standard form, which is this form, x minus h squared plus y minus k squared, squared equals radius squared, we have to do completing the square, a little process called completing the square. In order to complete the square, we will start out by rewriting it with our 9x squared first, and then our x's to the first power second. So we're getting our x's together, 36x. And then I want you to put plus a blank. Then we'll take our 9y squared, so it's positive 9y squared, and then our y's will go with the y squared, so minus 36y, and I want you to put plus a blank after. Then we put equals, then we're going to move our positive 8 to the other side by subtracting 8. So it's always going to become the opposite number. And plus a blank, plus a blank. Whatever we add here and here, we have to add to the opposite side as well. Before we're ready to add any numbers, before we're ready to complete the square, which is filling the blanks, we have to have a 1x squared. So we're going to factor the 9 out. So we have 9, open parentheses, x squared plus 4x plus a blank, close parentheses. Same thing for the y's. Before we can complete the square for the y's, it has to be 1y squared, not 9y squared. So we're going to factor out the 9, and we'll have 9 on the outside, y squared minus 4y plus a blank equals negative 8 plus a blank plus a blank. So we always move our constant to the opposite side, and it changes signs. So it went from a positive 8 to a negative 8 on the right side. Okay, now filling the blanks. So let me tell you how you fill your blanks. We are going to take half of b, half of the b term, and square it. So that is how you fill these blanks. And half of b squared. So your b term is the number in front of the x or the number in front of the y to the first power, x to the first power, y to the first power. So I just do this in my head. Well, I can show you half of 4. So half of 4 is 2. 2 squared is 4. So we add 4. And for the y's, half of negative 4 is negative 2, and negative 2 squared is also 4. Now, whatever we add to the left, we have to add to the right. I always say, when I get here, I would always say, but did we just add 4? No. Everything inside is being multiplied by 9. So we really added 36 to the left side, so we have to add 36 to the right side. And same thing here. Did we really just add 4? No. Everything inside parentheses is multiplied by 9. So we really added 36 to the left side, so we have to add 36 to the right side. Okay, now we're going to factor. I'm going to show you a shortcut for factoring. So 9, so I'll do it one time the long way, and then from here on out we'll do it the short way. So this has to be x times x to give you x squared, and a positive 4. This is going to be positive 2 times positive 2 to get a positive 4. And then the outside inside, if I multiply my outsides, that's 2x. Multiply my insides together, also 2x. And that gives me 4x in the middle, positive 4x in the middle. Okay, the shortcut is You see how we're going to get x plus 2 times itself? So in the next line, I'm going to write 9 times x plus 2 squared. The shortcut is, it is always going to be half of your b term. So my b term was a positive 4, so half of a positive 4 is a positive 2, and then squared. Okay, so let's try it. So over here, it's going to be plus 9 times, it's going to be y, and then half of my b term, half of a negative 4 is a negative 2 squared, equals, that's going to be 64. Okay, so I have plus 9 times y minus 2 squared equals 64. We're almost finished. Our goal is to get it into this form. We've almost got it. Notice that this is a 1 in front and this is a 1 in front. However, we have a 9 in front. So we're going to divide every term by 9 so that that can be a 1 out in front. So we're going to have, whoops, so we're going to have x minus 2, whoops, sorry, x plus 2 squared plus y minus 2 squared is equal to 64 ninths. And we'll just leave it 64 ninths. We'll just leave it in fraction form, and that's fine. And if we wanted to know where the center of the circle is located, the center is at HK. H is always with X, K is always with Y. It's always going to look like the opposite. So the opposite of positive 2 would be negative 2, and the opposite of negative 2 would be positive 2. So there's our center. And since that is your radius squared, that represents your radius squared. So if your radius squared is equal to 64 ninths, if we square root both sides, the radius is going to be square root of 64 is 8, square root of 9 is 3. Your radius would be 8/3. Although they did not ask us to find the center or the radius, we did it anyway. Number 15 also relates to a circle. This time we're finding the center and the radius of the circle. Here's our standard form for a circle, and we just have x squared plus y squared is equal to 1. So it must have originally been x minus 0 squared plus y minus 0 squared is equal to 1. So the center of the circle is always HK. H is with X, K is with Y, and it's always going to look like the opposite. So 0, 0. And our radius squared is equal to 1. So if our radius squared is equal to 1, and we want to know the radius, we will square root, and we have the radius is equal to the square root of 1, which is 1. So our radius is equal to 1. And there we've got that one. And normally I would always say to put plus or minus in front of your square root sign when you take the square root of a number. However, your radius is always a positive number, so there's no need to put the plus minus. A radius is positive. All right, and switching gears, this problem is about a hyperbola. Hyperbolas look like this. If the x's squared come first, then the hyperbola looks like this. So if you have the x squared over a squared minus, and this is how you know it's a hyperbola, you have a minus in between, and then you have your y squared over a number squared equals 1. Those are the hyperbolas that open left, right. If the y squareds come first, if you have y squared over a squared minus, because hyperbolas always have a minus, x squared over b squared equals 1. These are the hyperbolas that open up or down, up, down. So if the y squared comes first, it opens up, down, kind of like on the y-axis. Opening up, up, down is the y-axis. Left, right is the x-axis. So if your x's come first, it opens left, right, like your x-axis is left to right. That's how I remember it. So this one, I know that this is going to open on the y-axis up, down, because my y squared comes first. Now the center is again located at HK. So we have y minus 0 squared over 25 minus x minus 0 squared over 100 is equal to 1. So my center is located at HK. H is always with X, K is always with Y, and it always looks like the opposite, although there's zeros this time. So we have 0, 0 for the center. So I'm going to go to my graph paper. I'm going to put a dot on 0, 0. So now let me show you how this is going to open. On the y-axis, I'm going to count the square root of 25 on my y-axis because 25 is underneath my y's. That's how I remember it. So on my y-axis, I'm going to count the square root of 25. Well, the square root of 25 is 5. So from my center, I'm going to count up 5, and I'm going to count down 5. Up 5 from the center, down 5 from the center. And so I know since my y squared came first, it's going to open like this. It opens on the y-axis, up, down. It's going to open up, down, which is what your y-axis is, up, down. And then on the x-axis, I would move to the left 10, and I would move to the right 10. And I'm sure your teacher showed you how to put the little box in like this. You put a little rectangle, whoops, went a little too far. Put your rectangle in, and then you can draw your asymptotes. So the asymptotes are the diagonal of the rectangle, and that's actually how you get a better picture of how wide the hyperbola is going to be. Let me erase the hyperbola that I drew, and let me make it wider. It's going to follow alongside my asymptotes. So let me erase what I drew originally. That was just a little sketch, so we knew it opened up, down. And that is what it looks like. And let me clean up these little extra dots I accidentally made. Okay, that's what it looks like. So we can easily pick it from down here, from below. It should be, my vertices should be right here. That's a vertex, and this is a vertex, and they should be at 0, -5, and 0, +5. Those are my vertices. And it said find the vertices. Okay, and then we want to match it. So I'm looking for vertices at 0, 5, and 0, -5. It's got to be this one.